Okay, which questions are there?
So 33
Okay,
and 37
yes.
and 47.
Okay. Let's look at, other than that, you're done with all?
Yeah,
Okay, great. Okay, let's look at 33. So 33 said z is equal to ln y plus 2 minus ln y plus 1.
are
Express
you
y.
sharing the screen?
Yes,
Are you sharing the screen?
yes, I am.
I cannot see.
Okay, give me a minute. Okay, can you see it now?
Yeah.
Okay, so it's ln y plus 2 minus ln y plus 1, and they want y in terms of z. So I need to remove the ln, right? So to
Yeah.
remove the ln, there should be ln on every side, right? So let's put
Yeah.
an ln on z as well. Can I put an ln on z?
Yeah.
Yes, how can I put it? I can do ln e to the power z.
Yeah.
Yes. Okay, and this would be ln y plus 2 upon y plus 1 because there's a subtraction sign. So this would be e to the power z is equal to y plus 2 upon y plus 1. Now you need to make y the subject. So let's multiply this over here on the left hand side. So e to the power zy plus e to the power z is equal to y plus 2. Remember, I told you whenever you have something like this, you try to take it common, right? Whatever you need to make the subject. So I move all the y's over here and everything else on the other side. This is z, okay? This is not 2. Okay, so I take y common. E to the power z minus 1 is equal to 2 minus e to the power z. Y is equal to 2 minus e to the power z upon e to the power z minus 1. Understand?
Okay. Yes.
Okay. Let's move on to the next question, which is 37. Showing all the necessary working, solve the question. The equation is 3 2x minus 1 is equal to 2x. Give your answers correct to 3 significant figures. Now this you have to use the modulus laws. Do you remember modulus?
Yeah. Wait a second. I think this is the wrong question.
Okay. Okay, yes,
Uh,
this is the wrong question. Wait.
yeah.
Let me write 37. 37 says ln x to the power 4 minus 4 is equal to 4 ln x minus ln 4. And they want you to give your correct answer. Okay, they want you to solve for x. Okay,
Yes.
so I have ln x to the power 4 minus 4 is equal to ln x to the power 4 minus ln 4, right?
Yeah.
Ln x to the power 4 minus 4 is equal to ln x to the power 4 upon 4. Now you can just equate it. What you'll have to do is probably, let's see, wait, 4. You multiply it over here. 4x4 minus 16 is equal to x to the power 4. This becomes 3x to the power 4 is equal to 16, and you just solve it for x. Understand?
We'll take the root of 4. So root of 4, 16 over 3.
Yes, you'll take the root of 4, 16 upon 3. Okay?
Okay. Yes. Got it.
Got it? Okay. Then we have 47. All right. The last question. We have 3 to the power 2x plus 3 minus x upon 3 2x minus 3 minus x is equal to 4. give your answer correct to 3 decimal places. Alright. What we can do is, to make it simple for us, we can do 3 to the power x is equal to y. Okay, let's take this substitution.
Okay.
So this would be y, right? This would be y, yes? And
Yeah.
this would be y to the power minus 1, right?
Yeah.
Okay. Y squared plus y to the power minus 1 upon y squared minus y to the power minus 1 is equal to 4. Y squared is plus y to the power minus 1 is equal to 4y squared minus 4y to the power minus 1. Now what you can do is, you can change this into 1 upon y, 4y squared, or what you can do is, you can first solve. Y squared minus 4y squared is equal to minus 4y minus 1 minus y minus 1. This would be minus 3y squared is equal to minus 5y minus 1, right?
Yeah.
Minus 3y squared is equal to minus 5 upon y. This becomes y cube minus 5y cube is 5 upon 3. You take the cube root of 5 upon 3 and you get the answer. Understand?
Yes.
Once you get the answer, you'll put it over here to find x.
Okay.
Okay?
Yeah, just a second.
Yes.
All right, got it.
Got it? Okay. Okay, so today we're going to start with trigonometry. We're going to do the basics of trigonometry today. We're going to do both P1 and P3 trigonometry today, okay? I'm going to go through P1 trigonometry as a revision, and then we're going to do some formulas of P3, all right?
Okay.
Okay, all right. Okay, all right. Okay, first let's discuss degrees and radians. Start with the very basics. So we have two modes in trigonometry. We have degrees and then we have radians, right?
Yeah.
Okay. So 180 degrees is how many radians?
Um,
It's pi, right?
yeah.
So 180 is pi radians. Now this is the measurement that you'll use for every conversion, okay?
Okay.
Okay. Now I know 180 is pi, so 360 would be
2 pi.
2 pi radians, okay? How did I do this? This is also something you should know, and this is something also you can calculate. So 180 is pi, so 360 would be x. Then I cross multiply. So 180x is 360 pi. So x would be 360 divided by 2, which is 2 pi. Understand?
Yeah.
This is how you calculate it. But
Okay.
these conversions, the basic conversions, you should know. So for 180, 360, and 90 also, which is pi by 2. And the last is 45.
Pi by
Okay?
4. Yeah.
Yes. It's going to be pi by 4 radians. Okay? So these
Yes.
conversions you should know. Okay. Now there are some values that you should memorize, because there are times when they will ask you without using a calculator. Or even if they don't ask you, there are times when these methods will really help you with the question, okay? Okay, so we have degrees. Over here, let's make degrees. Let's also make radians. Then we have sine, cos, and tan. Okay, 0 degrees, 0 radians, 30 degrees is pi by 6, 45 is pi by 4, 60 is pi by 3, 90 is pi by 2. Okay, so these are the values for sine 0, like you'll read like this: sine 0, sine 30, sine 45, all right?
Okay.
So we have sine 0 as 0, cos 0 as 1, tan 0 as 0. Then we have sine 30 or sine pi by 6 as 1 upon 2. We have this is under root 3 upon 2. Then we have 1 upon under root 3. Cos 30 is under root 3 upon 2. And tan 30 is 1 upon under root 3.
Okay.
Then we have this. Your calculator can of course give you these answers, but you should also know these, okay?
Okay.
This means undefined. Okay, so this is a table that you need to memorize, okay?
Okay.
All right. Okay. These are the exact values, okay? Now let's talk about sectors. Are you clear till here?
Yes, ma'am.
Okay. Let's talk about sectors. So in P3 and even in P1, they give you some sectors in trigonometry, right?
Yeah.
These can also be known as sectors. They can also call it a Pac-Man. They can also call it a pizza slice. They can give different names to this. Just give me 1 minute. Let me see. It's not working. Okay. All right. So this is my circle. Okay. So basically, the idea is that this is the arc length, okay? So how do we calculate it? Angle. This can be, there are different formulas for the degree mode and the radian mode, okay?
Okay.
You've done this in your P1. So we have a formula for arc length, and we also have a formula of area of the sector. Do you remember doing this?
Yeah.
Yeah. So for arc length, the formula is theta
Theta
upon
over
360, yes, into 2 pi r. For radian mode, it's S is equal to r theta. For area, we have theta upon 360 into pi r square. For the radian mode, we have half rs, or if we put in the formula for r, which is the s, which is the arc length, it's going to be half r squared theta. Yeah.
Yeah.
Okay. So for example, they ask you, find the area of the shaded region. And they give you this is the shaded region they're giving you. Okay. This they've given you as 9 and this is 0.8 radians. Okay, how will you find the shaded region? Can you
With the
try to find
formula.
it?
Yeah.
Yes.
Can I look at the formulas?
Yes.
So it's 32.4
How did you do this?
half r square theta.
But that's the arc length, right? I want you to find the area of the shaded region. So what you're going to do is the area of the arc, shaded region would be area of sector, which you just found out, minus the triangle, right?
Yes.
See, this is the whole sector that you found out, the whole yellow thing. You'll have to minus the triangle from this, right, to find the area of the shaded region.
Yeah.
Yeah, and you know what's the area of the triangle? Half AB
Um.
sine C.
Okay. Yeah.
Yeah, so half r square theta minus half AB sine C. This is the formula for the triangle. And what is AB? AB is the length that covers the angle. So it touches the length that touches the angle, that is the length that you consider. So this is my angle, these are the lengths. Understand?
Okay. Yes.
You also need to revise the formulas for the triangles. Like you know how to find this length. Remember the cosine rule, the sine rules, everything. You need to remember revise those as well. Okay.
Okay.
Okay. So we have r square theta. So you just put in r the value of r, which is the radius, and you put theta. Then you put half AB sine C, and you'll get the answer. All right.
Okay.
Can you just solve this?
Okay. Yes. AB is 9 and 9, right?
Yes.
3.347.
Yes. Correct. Okay. Now let's move on to our quadrants. Okay. So there are two types of angles that we talk about. You've done this in P1 again. Okay. There is the theta that we consider, and there is a basic angle, right?
Yeah.
Let's talk about where the theta lies and where the basic angle lies. So we have 4 quadrants. Let's look at this one first. So for example, I have an angle over here as 10. Now for theta, we go from the x-axis to the angle, okay? So this
Okay.
is my x-axis. We go anti-clockwise and we go towards the angle. This is my theta. So theta would be what? 90 plus 10, which is 100. Okay?
Yeah.
Let's look at it in another quadrant. For example, I have 120. Okay? Again, I'll go from the x-axis towards the angle. Okay?
Okay.
So I know till here, what is it? It's 270, right?
Yeah.
So I can either do this, or what I can do is
360
I can
minus
simply
1.
yes, I can do theta is equal to 360 minus 120, which is going to give you 340. Understand?
Yes.
This is not 120, this is 20, sorry. Not even erasing. Just give me 1 minute. Okay. Yeah, this is 20 degrees. So 360 minus 20 is 340. Alright.
Yeah.
Okay. Now let's look at the basic angles. So for basic angles, what you need to consider is the blue ones, these are the basic angles, okay? There are 4 basic angles. Over here, it's in this quadrant. In the first quadrant, it's over here. In the second, it's over here. Third is over here. Fourth is over here. Okay?
Okay.
All angles with the x-axis, these are the basic angles, okay? Now you find theta. In the first in the first quadrant, theta is equal to the basic angle, okay? In the
Yeah.
second quadrant, it's 180 minus the basic angle. In the third, it's 180 plus the basic angle. Okay?
Yeah.
And the fourth, it's 360 minus the basic angle. Okay?
Yeah.
Now the last thing I want you to know about the quadrants is the signs. So in the first quadrant, all are positive, all angles are positive. That means sine, cos, tan, all positive. Okay?
Okay.
In the second quadrant, only sine is positive. Cos is negative, tan is also negative. Alright?
Okay.
In the third quadrant, tan is positive, cos is also negative, sine is also negative. And in the fourth quadrant, only cos is positive, tan and sine are negative. How you can remember this is all science teachers crazy. This is how we remember it, okay?
Okay.
So first, second, third, and fourth. Okay?
Yeah.
All right. Let's move forward. So, for example, they give you that this is 30. So, what would this be? This would be 150, right? Theta is 150,
Yeah.
180 minus 30.
Yeah.
Yeah. So, they ask you in the first part to find sine 150. So, you need to,
Okay.
from this, you need to remember that in this, the table that I gave you, we have sine 30, right?
Yeah.
So you need to remember that the basic angle of sine 150 is 30. So this is equal to sine 30. So whatever the answer for sine 30 is, the same answer would be for sine 150. So it's half. Understand?
Yeah.
But they won't ask you to use a calculator for this. They will ask you to give a reasoning. So this is why you need to know these angles, okay?
Okay.
For example, they give you cos 210. Okay? Now what you need to remember is for cos 210, what would be the basic angle? You always need to remember to go back to the basic angle. So let's make the quadrant. If it's 210, it will come for 210 till here, right? Till the
Yeah.
basic angle, right? So
Yeah.
if this is 210, that means it would have been 180 minus a plus something. In the third quadrant, it's always plus.
Yeah.
Yeah. So let's do 210 minus 180. What will it give you? It will give you 30,
30.
right?
Yeah.
Yes. Understand? So this is
Yes.
how I figure out the basic angle, which is
Okay.
a very important element of this chapter because sometimes they will ask you to calculate the value without using the calculator. So you need to tell that this is the basic angle, which is why it's going to be the same value.
Okay.
Okay. So this is going to be 30. So the answer would be the same as cos 30. And in the table, if you see, have you copied the table?
Yeah.
Yeah, in the table, you can see that we have cos 30, right? Which is under
Yeah.
root 3 upon 2.
Yes.
However, another thing now what you need to know is that in the third quadrant cos is negative, right? Only tan is positive.
Yeah.
So this will be with a negative sign.
Okay.
Understand? Try to
Yes.
do this question on your own. Tan 225 with the same method, okay?
Okay. So this is, for example, the fourth quadrant. If we take, that's the tan.
Yes.
But then 225 is not the angle with the x-axis.
225 is theta. We need to
Okay.
find out the basic angle now. What will be the basic angle? You tell me that.
Um,
So if I draw the quadrants, where will 225 come till?
the
It will
fourth,
come somewhere in the yes, somewhere in the fourth quadrant. How do you know this?
because it's tan.
No, because this line is 90, this is 0, this is
Right.
180, this is
Yeah.
270. So it will not come in the fourth quadrant, it will come in the third quadrant.
Okay.
Yeah,
Yes.
so it will come over here. That is how you figure out, okay? It
Okay.
will be somewhere over here. Now you need to find the basic angle. What is this angle? How will you find it out?
So 225 minus 180.
Yes, because in the third quadrant we do 180 plus the basic angle. So now you know theta, so you put 225 is equal to 180 plus basic angle. The 225 minus 180 would be the basic angle. Understand?
Yes.
So what's the basic angle?
45.
Yes. And do we have 45 in our table?
Yes.
Okay. So it will be the same answer. And what would be the sign?
Um, Negative.
Negative? You tell me again. All signs, teachers, crazy. In the third quadrant, tan is positive, all else are negative.
Okay, yes, yes, yes. Yeah, I was looking at the fourth one again.
What's the answer?
3 under root.
Under root 3?
Yeah.
Okay, great. All right, let me give you another question like this. Do these questions. Do tan 150. Do all the working and then tell me.
Okay. Okay, so I got negative under root 3.
Negative under root 3. Yes, great. Negative under root 3. Yeah.
Yeah.
How are you getting negative under root 3?
So first it's tan 150. 150 minus 90, which is 60. Tan 60 is under root
Why
3
would you do 150 minus 90?
because it's in the second quadrant.
So how do we calculate the angles in the second quadrant?
Uh,
Yeah, looks over here. How do we calculate angles in the second quadrant?
180 minus the basic angle.
Exactly. So it's going to be, you have to calculate in the second quadrant. This is my basic angle. So this would be, did you draw this? I don't think you drew this.
Right. I made the
Yeah.
angle with the y-axis instead of the x-axis.
Yes, exactly. 180 minus the basic angle. This is how we calculate it. I know
Right.
theta, which is 150, and I need to find the basic angle. So it's going to be basic angle is equal to 180 minus 150. So basic angle would be 30. Now tell me the answer.
So tan 30 is 1 over root of 3, which
Yes,
would
so
be
what would be the
negative.
answer? Yes, it would be negative 1 over under root 3. Okay. Calculate for cos 225.
Okay. Is it negative 1 over root 2?
Negative 1 over root 2.
Yeah.
Okay, so for this, you will be calculating for cos 45, right?
Yeah.
Okay, great. Yes, it's correct. All right, let's move on.
Will there be
I
questions which are not in the table you gave already? Like
No, no,
angles?
no. No, no,
Oh,
no. Those are the basic angles that you need to remember. Okay?
okay.
Yeah. All right. So what if they now gave you for radians? Now I want you to calculate this one.
Okay.
In the table C, we have written radians also.
Yeah.
Hmm. To make it easier for you, since it's confusing to know about radians in the quadrants, what you can do is, just for this beginning, you can convert this into degrees and see in which quadrant it is. Okay?
Okay.
So also in radian mode, the four quadrants would be theta is equal to the basic angle. In the second, we do pi minus the basic angle. Over here, we do pi plus the basic angle. Pi is 180, okay? Over here, we do 2 pi minus the basic angle, which is 360 minus basic angle. To calculate theta.
Okay. So since I converted it to degrees, so I look
Yes,
at the radians for it, like I got 60 degree. So cos
you got
60?
60 degrees. No, no. So you have to calculate cos 60, right? So
Yeah.
this is in the first quadrant.
Yeah.
Okay. So how do you calculate in the first quadrant? No, this is not cos 60. Did you calculate this in radians? It would be 120, right?
Yeah, and then 180 minus 120.
Yes, yes, yes. So now you can give the answer for cos 60. It's the
Okay.
same answer.
So,
Okay?
okay.
All
So
right.
negative pi over 3.
Negative pi over 3 cos 60. First of all, it's in the second quadrant, right? Okay. So why would it be negative pi over 3? It's half, right?
So we're okay.
The answer is half. This is the angle. This is the same thing. You can either write cos 60 or cos pi by 3. This is the angle. The answer is this. Understand?
Okay. The answer is
Both of half minus half.
okay.
Both of these lines are the same angles. So when you
Okay.
write it cos 60, you can also write cos pi by 3. I'm just
Okay.
asking you to convert to make it easier for you, okay?
Okay. So if I were to calculate this in radians, my answer would be the same.
Yes, the answer will be the same, but the angle would be pi by 3, okay?
Okay. Yes.
Yes, okay. All right. Um, let's do another question and then move on. This is P1, by the way. This is not P3. This is
Okay.
something you need to know for P3, but this is something that is tested in P1.
Right.
So calculate this now.
Is the answer 1/2?
The answer, yes, it's 1/2. Perfect. Okay. Now let's look at equation solving. Do you remember how to solve equations?
Kind of.
Okay, I'm just revising because I know you won't remember it properly. So let's just get clear with these steps before we move on. So we have equation solving. So for example, I need to calculate sine x is equal to minus half. So there are some rules that you need to follow. First of all, you look at the domain they've given you. So for this question, I'm giving you the domain x is between 0 and 360, okay? So there are some steps that we follow. First step, check if the domain angle is the same, okay? So first of all, we check if the angles are the same in the domain and the question. So in the question, what is the angle? The angle is x, right? And in a domain, the angle is also x. So that's fine. We tick mark it and we can move on, okay?
Okay.
Step 2, write down the quadrants. Okay? So what does this mean? This means that over here, my sign is negative, yeah? We're calculating for negative.
Yeah.
So let's look at the 4 quadrants. Where is sign negative in the 4 quadrants? It's negative in the
Um.
3rd and 4th, right?
Yeah.
Yeah, so we're just calculating for the 3rd and 4th quadrants. Okay?
Okay.
So in the 3rd quadrant, how do we calculate? We do 180 plus theta, plus basic angle. And in this one, we do 360 minus basic angle, right? So
Yeah.
this was step 2. Step 3, calculate the basic angle. No, first of all, you assume the angle is equal to the basic angle. What does this mean? Right now it's given as x, right? But they can give you 2x, 3x. So you just assume in this step you just write x is equal to the basic angle, okay? So now I'm
Okay.
going to write sine basic angle is equal to minus half, okay?
Okay.
In step 4, you calculate the basic angle. Now what do you do? Now whenever calculating, please remember that you ignore the minus sign, okay? Never
Okay.
put the minus sign in your calculator. That is just, the minus sign is just to know the quadrants, which we did in the second step, okay? That is
Okay.
all why the minus sign is needed. So over here, we're going to do sine. Basic angle is equal to half. Basic angle is equal to sine inverse of half. Can you put this in your calculator and tell me the answer?
One over 6 pi.
This is you're calculating for radian mode. Can you see the domain? The domain is in degree mode. Please
Okay,
take care of
sorry.
all that. Yes,
30.
30. So my basic angle is 30. Okay.
Right.
Step 5. Calculate all angles within domain. Okay.
Yeah.
So the basic angle is equal to theta, right? But we only want the angles for the third and the fourth quadrant, like we understood in the second step, right?
Yeah.
So, and we only have our domain till 360. So we only going one round. Okay. So
Okay.
the answer, this is not the answer. The answer would be for theta. So theta would be first 180 plus 30, right?
Yeah.
And 360 minus 30. Understand?
Okay. Yes.
You will be having two answers. This is something we calculated in the second step, the second, third, and the fourth quadrant. So this would be 150 and this would be 330. These are your answers. Understood?
Yeah.
So this is the calculation you have to do for every question. Now,
Okay.
these do not include the steps where we have uh, domain angle and the questions angle different. So that for those questions we have added steps. Okay.
Okay.
So let me give you a question. Now you can follow the steps and try to do it on your own.
Okay.
Wait. Cos x is equal to half. And I want you to calculate between 0 and 720. Do you know how to add angles? Like we have
Mm,
domain till 720. What do we do?
no, I don't.
Okay, just do whatever we did in the previous question, then I'll tell you, okay? Have you
Okay.
written down the question? I can show you the working then.
Yes. Okay.
Okay. You can see the working and follow the steps.
Okay. Is the answer 60 and 300?
60 and 300? Yes, that's right. Did you follow the steps?
Yeah.
Okay, great. Let me just do it. Okay, so it's positive, so it's going to be the first and the fourth quadrant, right?
Yeah.
Okay. Now let's assume x is equal to basic angle. Cos of basic angle is half. Basic angle is equal to, what is cos inverse of half? 60, right?
60. Yeah.
Okay. So now I have theta is equal to 60. 360 minus 60, which is 300. Now what you do, you have to go up to 720. Okay.
Okay.
So what you will do is you will keep adding. Once you have found the angles between 360, you will keep adding 360 to those angles until you reach to 720, okay? So first I
Okay.
will add 360 to this angle. So which will give me what? 360 plus 60 is 420.
420. Yeah.
Yes. Then you will add 360 to 300, the second angle. Okay, which will give you
660.
yes. 660. Okay. Now again, these are your two angles now. Now you will add 360 to these and see what
Okay.
you get. So when I add 360 to this one, 420 plus 360 is
780.
780. Do you see we're going beyond? So now
Yeah.
you don't consider this angle. Okay.
Okay. Yeah.
So you stop here. So these are your four angles between 0 and 720. Now, in case they have given you, for example, till minus 360 to 720. Let's see if they've given you this, okay? So what you
Okay.
do is, now these are your basic, the angles. Now you had added in these angles, right? Now you will also subtract 360. So I will do 360 minus 60 minus 360. So I will get minus 300. That is below 3 minus 360, right? So we also
Yeah.
consider this angle. Then you do 300, 300 minus 360, which will give me minus 60. So I have two added angles. Understand?
Okay.
Then
Yeah.
then you will also do minus 360 to these to check if they are within the range. Okay?
Okay.
Understood?
Yes.
Okay. Let's just stop here for today. In the next class, let's start with when we have to change domains also, and then let's move on to the identity formulas of P3. Okay?
Okay.
So tomorrow can I take your quiz?
Yes.
Are you prepared for it or do you need time?
No, I think I can do it.
Okay, all right. I'll just tell you the time for tomorrow by tonight, okay?
Okay. It's still logarithm, right?
Yes,
And the
yes.
first one.
Algebraic methods and logs.
Okay.
Okay? All right.
Yes.
Take care.
Okay, just one question. The first
Yes,
example you gave, sine x equals minus 1 over 2. We got
yes,
two angles, 150 and 330. We
yes.
also consider 30 as the answer, right? So there are three
No, we
angles.
don't. We don't. We don't. Why don't we consider it? Because in this question, my sign was negative. In the
Okay,
first, this would be in the first quadrant, right? Theta is equal to the basic angle in the first quadrant. And we are not considering the first quadrant. We are only taking the third and the fourth quadrant.
right.
If
Okay,
sign was positive, then we would have taken the first and the second. Okay?
okay. Right, makes sense.
Okay.
Okay, thank you.
No problem. Take care.
Bye.
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 Bye.